Now we are moving to another question coming under the topic of biomolecules, which came in GATE Excel Q in the year 2019, that is the question number 9. The question number 9 states that the electrostatic interaction energy between a positively charged atom A and negatively charged atom B separated by 3 angstrom in water is minus 6 kilojoule per mole. Considering the relative permittivity of water to be 80, the electrostatic interaction energy in kilojoule per mole, they have asked also to round it off to 1 decimal place between atoms A and B in vacuum is. So now here you are coming across a term, that is this electrostatic interaction energy. This electrostatic interaction energy. So first, now let us look into that what is the electrostatic interaction energy. So if you remember your physics basics in class 11-12, then you will know that these electrostatic interactions between any two charged molecules in space which is far by a distance of r, it is the electrostatic force between them is given by Coulomb's law. So in Coulomb's law, it states that the force, this is the electrostatic force, this is the electrostatic force, and this is equal to K in multiplied by Q1 into or multiplied by the Q2 divided by R square, where this R is the distance between the charges Q1 and Q2, and this K value. So what is this K value? K value is a measure of the dielectric constant in which these two charges are present, or the dielectric constants of the medium in which these two charges are present. Okay. Now, if we integrate this force with the help of dr, then we will come into this formula where this energy is given by E equal to kq1 divided by q2 divided by r. So here this r is the distance between q1 and q2, and q1 and q2 are the charges, and E here is the electrostatic energy. So in our question they are asking about electrostatic energy, and this is the formula of the electrostatic energy that we need to follow. Now what is K in mathematical form? So this K is equal to 1 by 4 pi epsilon. Now this epsilon is known as the permittivity of the medium, and this is also giving an idea about the dielectric constant of the media. Okay, so this value is given as 8.99 into 10 to the power 9. Okay, now this epsilon can be also divided, this is in under vacuum. Okay, now this epsilon is also related by the relative permittivity. Okay, so relative permittivity is given by epsilon r, and this epsilon, this that is the permittivity of a dielectric or dielectric of a medium, is given by epsilon r into multiplied by epsilon naught, which is the permittivity of free space or vacuum. So if you just transpose it here, you will find this, that epsilon is equal to epsilon naught into epsilon r. So these are the important things that we need to know while moving to the question. Now again I am reading the question. So here what they are asking about is that the electrostatic interaction energy is already given here, that is minus 6 kilojoule per mole. Then they are asking that these two charged molecules, there are two charged molecules, that is atom A and atom B, they are actually separated by 3 angstrom. So they have also given the distance here. R value is also given. And the relative permittivity, if you remember this epsilon r, this value, this is the relative permittivity of water, this is given as 80. Now what they want us to find is this electrostatic interaction energy which is given, that is for water, but what they want to find here is the electrostatic interaction energy in kilojoule per mole in the vacuum. So we need to find the electrostatic interaction energy in vacuum. the electrostatic interaction energy in water is already given as minus 6 kilojoule per mole. So what to do? So what are the given things? First we need to write that. So the electrostatic energy in water is given already minus 6 kilojoule per mole. Relative permittivity of water, that is epsilon r, is given as 80. Distance between two charges is given as 3 angstrom. And the electrostatic interaction energy in vacuum, that is we need to find. Now let us write the formula of electrostatic interaction energy. So as we have seen earlier, this will be Q1 Q2 divided by 4 pi epsilon into 1 by or multiplied by 1 by R. Now this epsilon can be again written as epsilon naught into or multiplied by epsilon R. Now already this epsilon R for water is given as 80, and we know that for vacuum it will be only epsilon naught because the relative permittivity in vacuum will be 1. So that's why this formula is getting into x4 by epsilon naught. Now just what we need to do, we need to divide 1 by 2, these two equations. Now you are getting the relation that electrostatic energy in vacuum equal to electrostatic energy in water multiplied by the relative permittivity of that in the water. Okay, and this value is already given as 80, and electrostatic interaction energy in water is already given as minus 6 kilojoule per mole. Just you need to multiply it and you will get into your answer, that is minus 480 kilojoule per mole. So this will be the answer of your question. Now for your reference, I have given you two courses that you can look into while going through the. Now for your reference, I have given you two courses that you can look into while going through the biochemistry and metabolism preparation for your GATE exam. So the two courses here is by Dr. Shagota Dasgupta of IIT Kharagpur. So the course name is biochemistry. So this is a very good course for going through your basics of biochemistry and the metabolism part. Also, there is another course by Professor Subramanian K of IIT Madras, and you can also go through this course to have a basic idea about this topic of biochemistry and metabolism.